Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to describe what are called the internal normal force, shear force, and bending moment. So what we're looking at here, imagine we have this beam attached to a wall, and somebody applies this force that I have shown here at an angle theta. Again, for this discussion, we're going to imagine that this force is very large compared to the weight of the beam. And what we're going to consider here is a free body of this part of the system. So what I'm going to do here is I'm going to cut this system and draw a free body of this piece of it. So again, I imagine this here. We're going to take that, draw a piece of it right here. Now, we know that this force is the force that's called F. This beam here has to still be in equilibrium. Therefore, there's got to be another force F in the opposite direction in this picture. And the only contact with this structure is actually right here. This structure is actually in contact. You know, if you look at our cut, I cut it right here. The right-hand piece can be thought of as in contact with the left-hand piece. So that force applied here, which is down and right, has to be up and left in this picture. Right. Now you'll notice that in addition to this force, if I imagine now summing moments about this point, you'll notice that this free body is showing a net clockwise moment. Well, that can't be because the beam is still static. So in addition to a force in this direction, we also have a couple moment applied to the left-hand side of the beam, which must be in this direction. Now, getting back to the force here, you'll notice that this force has both x and y components. If I go ahead and break that force into components, I've got a force this way and a force this way. This component, which is basically along the direction of the beam here, is called a normal. And this component, which is basically tangent to the cut, perpendicular to the beam here, is called a shear force. Most books use the letter V to represent shear forces. And if I knew this force F, I could easily find the normal force by summing forces in the x direction. That would give me the normal. I could then sum forces in the y direction to get the shear force. I could then sum moments about this point to get the internal bending moment. So that's a little bit about bending moments in internal forces. They're pretty easy to find. You find them by just cutting the structure at whatever location you want to find the internal shear normals and bending moments, and then drawing a free body of either the left or right-hand side of the structure. There's a sign convention that goes with this that I'd like to discuss before I end the video. Let's see. Let me get rid of this here. All right. So when we cut a structure like this, again, let me talk about this guy. I'm going to go ahead and redo that. If I cut it right here, actually I don't need the red in there. Sorry about this. Oops. There we go. So again, we're going to imagine cutting it right here. It doesn't matter where I cut it for the discussion, but I'm going to imagine cutting that right there. I think what I'm actually going to do is for my cut actually move this. Oops. Sorry about this taking so long here. I want that cut vertical. There we go. All right. I want to talk sign conventions. So when we cut a beam like this, and again, I'm talking about like mathematically cutting the beam, not cutting this with a saw. The assumed positive directions, let's see, on this side, is down for the shear, counterclockwise for the bending moment, and this way for the normal. And then any cuts on this side, being consistent with this in Newton's third law, remember that forces appear in pairs, equal magnitude, opposite direction, and the same thing with the moments. That means that this way would be the positive direction for this cut. this way the positive shear direction, and then this way the positive bending moment. So again, internal normal shear and moments are easy to find. You just cut the structure at whatever location you're interested in finding them at. Then we generally draw the shear, normal, and bending moment in their assumed positive directions. And then we use a pair of force and moment equations to find all these values. So I hope this video helps demonstrate these concepts. Have a great day.